Okay, I'm looking at taking some decimals and turning them into fractions. And we're going to do one of the more difficult ones, at least on this sheet, to do. We're going to look at number 5. 5 is, actually as a fraction, it's going to be a mixed number because it's greater than 1. But we're looking at 1.875. And what I tell my students when they need to write this in fraction form is that we kind of cover up the whole number for a second and we look at just the fraction part of this. 800 can't talk 875 thousandths, because we're going all the way to the thousandths place. And so they know what to do with that part. They know that that can be represented as 875 over 1,000. And then since the whole number part is here, we just put it right back in front of the fraction the same way that it's in front of the decimal point here. So 1 and 875 thousandths is what we're looking at. And they need to be getting these into the simplest form. Obviously, that is not the simplest form. And so we're going to look at how we do that. The students should be able to recognize pretty quickly that if a number ends in 5 or 0, it can be divided by 5. But I want them to recognize that if you're dividing 875 by 5 and 1,000 by 5, you're going to be dividing by 5 over and over and over and over and over again to get it down to the simplest form. I do not recommend doing that. Also, if you were making, students can't make a factor tree really for 875 or for 1,000, because the factor tree is going to be huge to list all of the factors that are going into that. So instead, when I have numbers that end in 5 and 0 like this, I think of numbers that I could count by to land on these numbers. And I recognize pretty quickly that instead of counting by 5s, I could count by 25s. I could count by hundreds for the 1,000, but I couldn't count by hundreds for 875 because I wouldn't land on it. So anything with a 25 at the end would help me. So I could, instead of dividing by 5, I could divide by 25, I could divide by 125, maybe even 225, something like that, to make it easier to reduce this in simplest form. So if it ends in 5 or 0, think about, instead of dividing by 5, we could try 25 or 125 or 225, 325, depending on how big the fraction is. So I'm going to start with 125 for this example. So if whatever I'm going to do to the numerator, I also have to do to the denominator, okay? Now, I'm not even going to have them set this up like a regular division problem, because it's not going to be easy for most 6th graders to do 875 divided by 125 just with standard long division. What I would have them think about instead is, how many times 125 is going to go into 875. And so this is how I would do that. I would kind of just walk them through it and say, we know that 125 and 125 together is 250. We know if we do that again, that's 250. And we know that 250 and 250 is 500. And 500 is getting me pretty close to 875. I could do, let's see, another 2. So we could do 125 and 125 again to get me to another 250. And now I'm looking at 500 and 250 together to give me 750. And I'm really close now. So let's see, 750 and another 125. If I'm adding those together, I finally get to the point where I see 875. And so I go back and I look. It took me, let's see, 1, 2, 3, 4, 5, 6, 7. 7 times 125 equals 875. So 875 divided by 125 is 7. So I've been able to reduce the numerator at least all the way down to 7 just by being able to add up 125 pretty quickly. It's a lot faster than doing a factor tree or dividing multiple times by 5.